Hi everybody, Dimitri here from Streamscape. Welcome to another edition of Streamscape TV, and we're going to talk today a little about Semantic Mapper and how the Semantic Mapper can help you prepare and mobilize your data for analysis. The Semantic Mapper is a pretty powerful tool. Not only does it allow you to do data transformation, but it also understands data structures. It is data-centric and data-aware, and it provides a way for you to tap into a domain-specific data model without the need for a database. So a little bit about how it works. Semantic Mapper effectively is part of the data fabric, and it can sit on top of enterprise applications, SQL and NoSQL databases, web and cloud apps, message queues, or batch files, and effectively allows you to transform and enrich data as it passes through the mechanism and tap into all of the enterprise storage underneath. Your request comprised of one or more objects can be sent into the mapper. The mapper then uses the rules that are part of it to transform, enrich, and potentially perform I/O on the data that you supply. The result is a response object, and then that response object can be used to feed further downstream systems or be a result in a REST call. So let's take a look at how you would actually use this in real life. Okay, we're going to be using Application Workbench to illustrate a fictitious example where we take a name of an employee. We're going to perform an address lookup in our application data space, and then we're going to provide a result which is going to be a combination of the address and the employee name. Now, the objects that are used by the mapper and everywhere else in the fabric are actually referred to as semantic types. So these are user-defined types. They're objects or documents that you can use in order to group and represent real-world things, like an employee. Let's take a look and see if we can find one here. The type browser allows you to go through and filter through a lot of these. Typical implementation, you're going to have quite a few of these. We've had several that had hundreds of different types. But here we go. We've found an employee. In fact, we found two of them. One can potentially be an ancestor of the other because we do support inheritance, hence the concept of semantic types. And in fact, employee APAC looks like it's a derivative of employee. We'll get to that stuff later in a separate session. For now, let's inspect the object and take a look. So this object is pretty straightforward. You've got a first name, a last name, age, department, and so on and so forth. Pretty standard bit of information about an employee. We're going to be using that in order to create an address. And so let's see if we can find an address here. And it looks like we have something called AMP address. If we take a look at that object, you can see that it's a pretty standard address that potentially goes on a mailing label. Address line 1, line 2, city, state, and so on and so forth. So what we'd like to do is create a mapper that is going to transform one into the other by doing a lookup in our application data space. Data spaces are a computing abstraction. They provide a mechanism for storing data in memory, for virtualizing access to data storage in relational databases, non-relational files, queues, or wherever else you want. In this case, we've created a data space that holds a very simple employee address. We can actually take a look at the list of addresses in here. You can see that there's a series of folks that have been put into our table. So very similar to the diagram that we showed earlier, we're going to be taking an employee, doing an address lookup, and merging that bit of information together. When you start creating a mapper, really, it's fairly straightforward. You go to Mappers under your engine runtime, and you would create a mapper that allows you to give it a name. And you would supply the source types and the target types. So you would add a semantic type, for example, like the one that we were looking at before. And here we have found employee, so we're going to select that. And then we're going to select our target type, which is going to be the employee address. Now you'll notice that there are validations that can be enabled for source and target. These validations, when enabled, will actually attempt to validate the contents of the object that you're sending in. The object or document, the term is used interchangeably, can have validation rules put into it and declared on it so that you can, for example, check for things like the length of a first name, length of last name, and so on and so forth. In this case, we're not enabling source validation for the sake of this example, so that we don't get bogged down with some of the more advanced features. Now, we have a data space that we're going to select. We're selecting a table space called address book. And we're going to finish up. And you'll note it will create a series of source things that I can do stuff with. And it creates a series of targets. And so in between them are going to be the mapping rules. Typically what you would do is drag and drop your content from one place to another like so, and go on and create these lines that visually represent the mapping, and then go and edit the rules. So editing the rules is a pretty straightforward process if you know the syntax for how to do that. You'll notice that there are simple assignments, which is probably the absolute simplest way of doing these mappings, and of course you can get more complex as you gain more speed and knowledge. You'll notice on the right-hand side that there's a set of tabs or drawers for collections, functions that can be used. Here are some user-defined ones, and there are also operations. So the rules language for actually mapping all of this stuff is pretty sophisticated and allows you to perform very simple to very complex operations. Collections can be accessed directly from here. The emp addresses collection that we were looking at before actually can be used in transformations, and so you can simply pull it in here and perform some operations on it, or you can use auto-completion in order to see what else you can do with it. In many cases, users might have to do some specified or specific custom transformation. In that case, you can make use of user-defined functions or a list of functions that we have available for analytics, aggregation, and so on and so forth that are available as part of the data space. All of this stuff is intermixed, so you can freely use any user-defined functions, any system functions. You can compose them. They're composable, so you can stack functions inside of one another, and you can pass parameters to them from source objects and from targets. This example steps you through something that has already been created. So we're going to take a look at the next step, which is what does a completed mapper look like. So here we have something called a resolve addresses mapper. As you can see, it actually visually represents exactly what the operations are and what relationships all the various variables and operands have. You can take a look at a rule which is a little more complicated, such as the one here. You can see that we're actually taking an address label 1, and we're assigning some information to it. So we're pulling in employee first name, employee last name. We're creating something which is a soundex code, which is a sound-alike code that's assigned to a first and last name. And this is actually using a user-defined function that we can find here. For the purpose of this example, the functions have been created for us already, but to the question of what can we do with these functions, you can put any logic you see fit into these functions, which can perform anything from a simple operation to stuff like joining of foreign databases or making a web call out and so on and so forth. So let's take a look real quick at what a function syntax looks like. Okay, in this case we have a really simple function that basically takes a first name and a last name and wraps that into another function which is a soundex function that returns a code that represents first name and last name. We're really doing that because we're setting up for a following example which is going to try and find the actual names based on what they sound like. It is outside the scope of this particular example, but just goes to show you what the level of complexity can be when working with data spaces and with semantic mappers. When the mapper is complete, and you can take a look at the various rules that have been set up, Its purpose is to take data from the left-hand side, which is on the inbound, perform all of these translations, all these rules, and then produce an output artifact, which is the emp address object. That object can then be rendered as XML, it can be rendered as JSON, it can be used in a web callout, and you can very easily test and create data services, which are effectively microservices that can then be published out to anywhere on the web. It should be noted that semantic mappers themselves are fairly versatile entities. They can be used in a variety of places. You can use them for inline transformations inside of the query language. You can use them inside of replication definitions so that you can transform data rows and so on and so forth. And you can use them in services to actually create a semantic mapper service that can then be invoked from a variety of interfaces, such as SQL, web callouts. You can use messaging to actually pass messages into the mapper and to get results back. So let's take a look at how you would configure a service. Once a mapper is created, you can actually wrap it in a semantic mapper service, which allows you to specify the service's name and so on and so forth. Select exactly which mapper you want to use, and provide some basic information like request IDs, response IDs, and so on and so forth, so that you'd be able to match up requests and responses. You can also set up the expressions so that the user would know where to pull this information out of. Alright, let's skip ahead a little bit and take a look at a pre-configured service. So you can see that our employee alias is here. It's pointing to the current object, which is going to pull out of the event that's given to it. And you can see that there's a response ID. Now, this is configured in such a way for two reasons. We support multiple invoke models, one of them being that you can send messages or raise events to actually get the information back. The other one is that you can actually do a direct invoke or call from a browser or from SQL or from other request response mechanisms. Once all of this stuff is set up and you've basically configured your semantic mapper to be used in the service, you can step through the rest of the configuration where you can set this up for performance to be a pool of services if you wanted to. You can give it a little more memory if you want to, and you can really create a whole cluster that can process the employee lookup requests. Once all of this stuff has happened and we've stepped through the basic configuration steps, we register the service. All of this is done for us by the wizard. And once the wizard finishes its job, you should have something like this created, which is our mapper object right here. The semantic mapper service is now ready to go. It has been started up. Okay. To test our service, we're going to use the browser. We're going to point the browser at the node. Here we are on port 8003. SOR is a special area within the node where you can actually go to like a mini catalog that you can look up your services and some of the other stuff that's out there. Here we have our resolve address service that has been set up, and it's in fact giving you all the information that you need. Okay. To test the service, we're going to go into our object repository, and every node has one of these, and you can actually connect up to it. It has a secure login. Once you're in, you can actually take a look at some of the things that are deployed in the node. In this case, we take a look at our service, and there it is. We have our resolve address service, and you can peruse it and browse some of the facts and information about it. For instance, if you actually click on it, it'll give you some basic information about its deployment. It's going to, in fact, generate for you a URL to actually go out and call the service, and it's going to give you some additional information about what some of the inputs and outputs of a particular service are. So here you can actually browse this information and get an idea of what to expect. This is good for web developers that actually want to call the service directly from an application or from another client. taking a look at something like the mapping handler, event handler, you can take a look at the inputs and outputs, and you can see our employee object that's coming in, and you can see the response object, which is the employee address, and you can drill into these and take a look at further information. So this allows you for online documentation of what some of this stuff looks like, and you can see that in some situations we could define validation rules that we talked about earlier, not null, length, range, domain. These are all things that actually can be defined as basic validation rules for any of these objects. The great thing about the object repository in the browser is that developers and users alike can actually take a look at objects. Documentation is automatically generated for you. They can take a look at what some of this looks like if they were sending and receiving data, and they can do a preview, for example, in JSON format. So let's go back to where we previously were. Take a look at what the Semantic Mapper definition created for us, and you'll see that there's a GET call that is actually automatically exposed, and in fact shows you the URL plus the object that you can pass into it. In this particular case, I've already taken the liberty of pasting that into another tab, so we're simply going to look up the name. So we've put in Tony Stark in here as the name, and you can see that it actually returns back some information. So it returns back a full label with a soundex, and it returns back a full secondary address label and some basic information that we had before. So in this case, what we're actually doing is we're passing the employee information in. We're getting that data from the data space, enriching the information, and posting it out here. This is a great way to use the browser to actually test your transformations. As you can see, it takes a few minutes to set this stuff up and get going with it. There's no complicated import, export, or code compilation. We can, in fact, change some of these values here just to make sure that we're actually doing real lookups. So we'll change Tony Stark to Peter Parker and see if we actually get, maybe hit on that name as well to see if we get some additional information back. And sure enough, we get Peter Parker with a different CDX ID, and he seems to be residing in Forest Hills in Queens, New York. So just to verify that we are indeed pulling it from the data space, we can go back here and take a look at what we were looking at earlier. Oops, where is it? And take a look at our addresses, and you can see that we have various characters in here with their respective addresses. So we indeed went through, performed enrichment using the data space, and gave you back a result. Data spaces are a computing abstraction, as was mentioned earlier. So in this particular case, we are hosting all of this stuff effectively in memory. The EMP addresses exist locally in our address book data space. However, the data space can be configured to use virtual tables, views, event tables, maps, and other types of data collections that can make use of virtual servers such as SQL and NoSQL, and they can pull data right out of messaging systems or files if need be. This gives you the ability to reach out to any data source and to pull information into the mapper from anywhere, whether it's files, whether it's remote databases, and also allows you to perform cross-platform and cross-resource joins where you can pull this information in and make it part of the mapper. As you're defining and describing all of this information, you can see that it is visually giving you a hint and a set of clues of where the data is coming from, so that another user or yourself, if you've forgotten how this maps, can easily take a look and see where the data is coming from and where it's mapping to. So that's Semantic Mapper in a nutshell. Thank you for joining us for Streamscape TV. We'll see you next time.